Welcome to our next video in the Algebra 2 series, Number Sets and Real Numbers. To begin, let's look at what real numbers are. The real numbers are all the numbers that you've seen up until you start taking Algebra 2. That includes numbers like 3, 2.4823, 1/2, 5 pi, etc. And what you would have seen so far with these real numbers is that most of the time we use them when we're graphing on a number line or a Cartesian plane, which is just the name for our x and y axis that we use to graph lines, parabolas, and other stuff like that. Now, these numbers, these real numbers, are the most common numbers we'll be using in Algebra 2. But later on, we'll also introduce new number sets that you would not have seen up until this class. Our real numbers, broadly, can be divided into two special categories, the rational numbers and the irrational numbers. Each of these are defined by different types of numbers, and together they create the real numbers. Then the rational numbers we can also divide into smaller sets, and we'll look at those as we go through the next few slides. To begin, let's look at the irrational numbers. Irrational numbers include our non-terminating, non-repeating decimals, our irreducible roots, and our numbers that include an irrational number like pi or e. Here are a few examples. Next up, we have our rational numbers. And the rational numbers are the real numbers that include all of our fractions that have integer numbers, our terminating decimals, and our repeating decimals. Here are a few examples. The rational numbers can also be cut into the integers. The integers are the portion of our real numbers that include the whole numbers and their opposites. So if you think about that, that means if we get rid of our fractions and our decimals, we now have the integers. Here are some examples of integers. The integers can also be cut into the whole numbers. The whole numbers are just our integers that include the natural numbers and 0, but not the negatives. That means if we get rid of our negative numbers from the integers, then we now have the whole numbers. And here are some examples of those. Finally, we have the natural numbers, also known as the counting numbers. These numbers are the numbers you first learn about when you start getting into school. It's the 1, 2, 3, 4, the things you would naturally count as a child. These natural numbers, then, are our whole numbers, but they don't include the number 0. And here are some examples. Now here's an overview of our real numbers. Altogether, everything we talked about creates the real numbers. And they're divided into those two big categories, the rational numbers and irrational numbers. Those rational numbers, if we cut out the fractions and decimals, create the integers. The integers, if we cross out our negatives, create the whole numbers. The whole numbers, if we cross out 0, creates the natural numbers. And altogether, we can think of them as one giant set of numbers when we put them together like this. Now, real numbers have some special properties that are going to be useful as we go through our classes. First up is the addition and multiplication properties for closure. Closure means that if we add or if we multiply two real numbers, we get a real number as an answer. So I can take 2 plus 7.2, I get a real number. I can take 2 pi times 5 square root of 7, and I get a real number. Properties of real numbers also include the commutative properties for addition and multiplication. when we add real numbers, we're allowed to switch the order we add them in. I can take 5 plus 7, and that's the same as 7 plus 5. Same thing with our commutative property for multiplication. When I multiply real numbers, I can multiply them in any order, and it's not going to change the answer. 5 times 2 is the same as 2 times 5. And I like to remember the commutative property by remembering the word commute. When you commute to school, you move to school. When I commute a number, I move the numbers. Then we also have the associative properties for addition and multiplication. The associative properties allow us to switch the numbers we look at without actually moving where they are. Meaning, I can put parentheses around different groups of my numbers as long as I'm just adding or multiplying them, and I won't need to change the answer. So if we look at these examples, we have 2 plus 1 plus negative 1, parentheses around the 2 and the 1. That's the same as 2 plus 1 plus negative 1 with the parentheses around the 1 and negative 1. It's not going to change the answer no matter how we associate the numbers. Works the same way with multiplication. If I have 2 times 1 times 8 with parentheses around 2 times 1, that is the same as 2 times 1 times 8 with the parentheses around 1 times 8. Doesn't matter where we put the parentheses when we're dealing with addition or multiplication of real numbers, we can move them without changing the answer. Then we have what are called the identities for addition and multiplication. The identities are numbers that we can either add or multiply to a real number without changing what it is. For addition, we have the additive identity of 0. If I add 0 to anything, I get the same number back. 0 plus 11 is 11. For multiplication, our multiplicative identity is the number 1. If I multiply 1 by anything, I get the same number back. 1 times 27 is still 27. These additive and multiplicative identities are part of our real numbers. Then we also have what are called the inverses for addition and multiplication. The inverses are the opposite numbers, and there's two ways we can think of these opposite numbers. We have the inverse for addition. These are two real numbers that when we add them up, give us an answer of 0. So if I take a number and it's negative, those are going to be our inverses. 2 plus negative 2 is equal to 0. Negative 5 plus positive 5 is equal to 0. The positive and the negative of a number are inverses for addition. When we talk about multiplication, we want two numbers from our real numbers that multiply to give us 1. So if I take any number and turn it into a fraction, its reciprocal, that creates our inverses. 2 times 1/2 is equal to 1. 1/4 times 4 is equal to 1. Those are our inverses for addition and multiplication. Then the last of our properties is the distributive property. When we work with real numbers, we are allowed to take any real number outside parentheses and distribute it by multiplying it to everything within the parentheses. Now that can be 2 numbers, it can be 3 numbers, it can be 64 numbers. It doesn't matter how many numbers are in the parentheses, we are allowed to distribute it to all of them. So if I have a times x plus y, I take a times x plus a times y, distributing the a to everything within our parentheses. That concludes our look at the real numbers and some number sets. Next video, we're going to start looking at how we can work with real numbers and solving equations.